Okay, well, I was mid-sentence when it cut off. Okay, sorry. All right, so number 2 is find the z-score that has 10% of the distribution to the right. All right, a couple of things. So percentage, we need to change it. So it's 0.1075. And then this is to the right versus everything else was just to the left. We can do a couple of things. We can, remember the rule is 1 minus the number for the right. Like a colon. Okay, and so we can do 1 minus that number and we'll get 8925. Or we can just go in and type, like we're trying to normalize it. Okay, and so notice that regardless if I type in the 1075 or the 8925, the exact same answer because the normal distribution is symmetric. One's positive, one's negative. You can never have, so we would have to figure out which one. And so that's where, our what-wo lies. So you can type it in your calculator. You just really need to remember that you do 1 minus the number. And then if you want to look it up on the chart, you find that 8925 because we did 1 minus. And it's right here. And then we go up the number from the hundreds, and this is the whole, and then the tenth. So 1.24. 1.24 rounds. All right, I want to talk about these kinds of problems. So a z-score that corresponds to each percentile. So for example, this guy would be like, a school wants to only accept the top 5% of ACT scores. Or a study wants to be done on the middle 50% of the data of persons that fall within this data, so that there's no like super big outliers. Or you could say this is like if it would be to the right. So like the 10%, 90% is 100. So you would say like only the top 10% could be asked to join the firefighter academy or something like that. And so you would do P of 90 because it's to the left, and then do the subtracting one. Let's do those. The z-score that corresponds to P5, that means 5%. So we're going to change 5 decimals here, percent. So 0.05, which is right here. And so 0.05. You can type it in your calculator and you get this, 0.05. If you want to look it up on the Z chart, here's where it gets confusing. Okay, 0.05. There's not a 0.05. Look at these right here. So you can't go above it, you have to go below it. Okay, and then we go backwards. So right here, that's negative 1.6, and then we would go up this column, and it's 0.05. So negative 0.65, or negative 0.64. So, depending on if you use the chart or the calculator, either way is fine. So this means, okay, yeah. So now let's do 50%. Okay, 50%, so 50. The decimals here, move over twice, and so that's why we get 0.5. So type in your calculator, INV norm 0.50, we get 0. Let's see. chart. What was it, 0.5? Oh, 0.5. Point. Oh, I'm looking the wrong direction. 0.5 is right here, and it's an exact, happens to be an exact number. So we get 0, and then this, if you go all the way to the top of that column, it's also 0. Okay, what if it was positive 0.5 right here? 0.5 is also right here. There's a 0 and a 0. So you still get 0. Just easier to type in the calculator if you can remember the function. So INB norm 0.05. We got negative 1. Right, INB. So it would be INB norm, and we did 5. We still got 0. Do the next one. Z-score for 90. So this is 90. And then go over, so you get 0.9. Okay, so this represents 0.9. See it? All right, so 0.9. I'm just going to INB V 0.9. You get 1.28. Part of the equal sign. All right, so we get 1.28. If you look on the chart, it's kind of confusing because what we need is 0.9. And 0.9, so this is 0.9015, and this is 8997. So we can't go over it. So we need to use this guy. And so that's 1.2, 997, and 0.8. We still get 1.28. Okay, and so 1.28. All right, let's look at, I don't want you to learn another formula. Our formula is x minus mu over standard deviation. All right, so a veteran records weights of cats at the clinic. The weights are normal. The mean is 9. Standard deviation is 2. And so we want to find these z-scores. All right, so this is the formula for z. And so we're going to go backwards, okay? And so what we're going to do is for this 1.96 equals, we don't know, minus 9 over 2. And so to solve this, I'm going to do times 2 on both sides. I get x minus 9 equals 2 times 1.96, 3.92. I'm going to add 9 on both sides, and I get 1292. Right, 1292. For the negative 0.44, negative 0.44 equals, we don't know, minus 9 over that 2. Do the same thing. I'm going to multiply by 2 on both sides because I need to do the opposite operation. Remember, the opposite operation of division is multiplication. So negative 0.22 times negative 0.88 equals x plus minus 9. I need to add 9 to both sides. I get 8.12. Okay, so that was one of them. That's the other one. All right, and the other one was 0 equals x minus 9 2. I'm going to multiply by 2 on both sides, so I get x minus 9 equals 0. I'm going to add 9 on both sides, and I get 9. Of course I get 9. This makes sense. The mean is always 0. And so if we're sitting over here at 0, then we're going to be sitting at the mean. Here's what it means. Here's what it implies. Okay, 12.92. If the mean is 9, that means 12.92 is above the mean. the mean is 9, that means 8.12 is below the mean. And if a cat comes in weighing 9 pounds, then it is equal to the exact mean. And so we found like this would be a cat weighing 12.92 pounds, which was almost 2 standard deviations above the mean. Here, a cat comes in weighing 8.12 pounds, and that is 0.88 standard deviations, like down, negative. And then this is a cat comes in weighing 9 pounds, and they weigh exactly the same as the mean. All right, and so scores for California police officer standards, normal distributed, mean is 50, standard deviation is 10. They only hire applicants from the top 10%, so just like that problem I was talking about. What's the lowest score you can get? Okay, so we want to know the score. Okay, we're at 0.10. So I need to find the appropriate z for that. Okay, 0.10. So I'm going to do, to get the appropriate z-score, you can look it up, 0.10, and what's closest, and then go out. Or we can do the INV norm of 0.10, which is what I'm going to do. Second bars, INV norm, 0.10. I get, this 0.10 is not the z-score, it's the percentage. So I'm going to do the calculator. And for my z-score, I get negative 1.28. All right, and so my formula is, here we are. It is x minus mu over standard deviation is z-score. So x, we don't know, minus mu over standard deviation is negative 1.28. All right, so I'm going to multiply by 10 on both sides, and I get, bring it down over here, okay? X minus 50 over 10 equals negative 1.28. That I can. All right, I'm going to multiply by this 10 because I want those to cancel. And I get x minus 50 equals 12.8 negative. I'm going to add 50 to both sides. $37.2. So I get x equals 37.2. So the lowest score, oh, you know what? Messed up, because what I found was I did the lowest 10%. How do I know I did the lowest 10%? Because right here, my z-score was negative. We don't want a negative z-score. That's way over here. We need the top z-score. All right, so what I need to do is I needed to do the opposite, right? So the opposite, this is not really the 10th, this is the top 10%, which corresponds to the 90th. So I need to do 0.9, and I will get a positive 0.9, 1.28, positive, positive, add 50, and I get 62.8 is the lowest score that the person could get in order to qualify for whatever this was, the police officer. All right, I'm going to do the next problem in another video. So I'll see you in a minute.